Printed circuit MEMS fabrication begins with laser cutting complex patterns into thin layers of structural materials and adhesives. These layers are stacked and aligned using precision pins. Heat and pressure bonds the layers together into a flat laminate. These laminates can be micromachined again, and combining rigid and flexible materials allows us to create mechanical structures with rigid beams and flexible joints. While fabrication allows us to create complicated flat structures, pop-up folding and locking allow us to assemble these flat structures into three-dimensional machines, similar to a pop-up book. A release step completes the machine by removing any extraneous components. PC MEMS allows a wide variety of materials. This cross-section view shows Mobee uses 5 layers of carbon fiber for rigid lightweight components, 2 plastic layers for flexible joints, 2 brass layers for locking, 1 layer of titanium to mimic insect wings, and 2 piezoelectric ceramic inserts for actuation. 8 layers of adhesive bond to stack together, creating an 18-layer laminate. Each layer is machined with a different pattern. This top view shows Mobee's design with different colors corresponding to different layer stacks. Viewing the actual device, the majority of the structure is dark carbon fiber. The central piezoelectric ceramic trapezoid, the purple titanium wings, and the golden brass pads are also visible. This flat laminate relies on pop-up book folding to achieve a three-dimensional structure. Mobee is fabricated as 2 parts, the actual machine components, and a surrounding mechanism called an assembly scaffold. The assembly scaffold's purpose is to link all complex origami folds into a single motion, like a pop-up book. Let's take a more detailed look. The assembly scaffold consists of 2 plates, and separating these plates is the single motion that will fold the monolithic bee. To make sure these plates do not tip or tilt, simple linkages are placed on the perimeter, forming what is known as a Sars hinge. Similar linkages on the interior are connected to each of Mobee's components, causing them to move when the plates are separated. Here, the side of the airframe undergoes simple rotation. More complex motions can be created by combining multiple interior linkages. Here, 2 linkages form a parallelogram that keeps the wing level. Mobee uses 9 interior linkages in total for three-dimensional assembly. In the actual structure, 6 pins push on the top plate from underneath, separating the assembly scaffold plates to actuate folding assembly. The folding process can occur quite rapidly. The entire device is then immersed in a liquid metal solder, which bonds selectively to the brass pads. This locking process allows Mobee to be removed from the assembly scaffold without unfolding. Finally, Mobee is released by laser cutting all connections between the scaffold and the device itself. It can then be removed and is ready to operate. Applying a voltage from an external power source causes the wings to flap, first at 1 Hz, and then at 30 Hz. Printed circuit MEMS is a versatile process for creating machines at the millimeter scale. It can create complex electrical and mechanical systems using a variety of techniques. It is a process well suited to mass production, enabling parallel manufacture of large numbers of robotic devices.